Okay, so tonight what we're going to get started with is just kind of reviewing some basic chemistry ideas. So the first thing we need to do is just discuss matter and kind of the particle model of matter. So particle model of matter takes the idea that all of our matter is always vibrating, all of our atoms are constantly interacting and slipping and sliding and vibrating and constantly expelling energy against each other. So we're going to start with our idea of all matter. And we can kind of just divide that up into some smaller subcategories. So the first one we need to break it up into is the idea of pure substances. Everything that's not a pure substance will be a mixture in some way, shape, or form. So our pure substances, the most important one to discuss is going to be our elements. So an element is going to be any substance that is made up of one type of atom. So if we are talking about magnesium, magnesium is only magnesium. There's nothing else going on inside of there. All of the atoms in a sample of magnesium are simply magnesium. Nothing more, nothing less. The other type of pure substance we have is a compound. Now, when we talk about compounds, it's slightly more difficult to discuss them as a pure element because although they are pure, they are all the same compound. They are made up of multiple elements. So if we're talking about level of purity, I'd go element, then a compound. But all the same, when I'm discussing water, in a glass of water, everything is one homogeneous unit all the way through. The whole glass is filled with the same compound. It is purely water all the way through. When we talk about mixtures, we break it up into two fundamental groups. We have solutions, and a solution is a homogeneous mixture in fluid. So when we talk about a solution, we are generally just talking about, salt dissolved in water, or some sort of ion, or some sort of mixture of fluids together, ethanol, water. It is not one substance all the way through. Over here I have H2O. A glass full of H2O is pure. It is just water. Or a glass full of ethanol is pure in water. But if I mix those two together, I now have a solution where some of it's water, some of it's ethanol, some of it could be something else. We're talking about a mixture, and even though we can't tell the difference between it, we can measure it out using science, and we know for a fact that it is not pure all the way throughout. And our other kind of mixture is going to be a heterogeneous. Make sure I can spell heterogeneous mixture. Now, a heterogeneous mixture, I think of these most easily as like a salad. I can very clearly see what's inside of there. I can see the lettuce, the croutons, the dressing, the cheese, whatever's inside of your salad. I can tell all of the different components inside of it. Same with a heterogeneous mixture. So those are all of our different classifications of matter. Now when we're talking about this, I want to take this into a particle model of matter standpoint. So just flipping this page over, we are now going to talk about our particle model of matter. So I want you to always be thinking, when we discuss this, that our matter is in one of three states, whether it be a solid, where things are rigidly placed together, a liquid, where atoms can easily slide over top of each other, or a gas, where atoms can fly around completely at ease, independent of anything else. These three different states kind of describe everything going on with our matter. So we've classified it out. This is how it actually interacts at the subatomic level. If we were to actually look at it, this is how it's reacting. We've talked about our classifications of it. The other thing I want to discuss is just going to be relative size. So I think it's important for us to always know what begets the bigger thing. So this biggest thing we're going to need to talk about all the way through grade 9 in high school is going to be the electron. So this is our smallest. I'm also going to get a better pen. So electron is going to be our smallest. Our next size up, we are moving up to a proton. Protons are going to have a positive charge. They're slightly larger than electrons, which have a negative charge. Neutrons, slightly larger yet no charge. When we start combining our three subatomic particles together, we end up with the atom. So our atom is going to be kind of our fundamental unit that we discuss all the time. So this is made up of protons, neutrons, and electrons. So when I discuss our matter, understand that when we talk about atoms, it's made up of neutrons, protons, and electrons. So we're going to kind of put a little divider there. Then atoms are used to make up molecules. From there, we now can break this off into our idea of an element. And from there, we break it up into a compound, and so on and so forth, all the way through our original list. So this gives us a relative sizing. This kind of sets us up with how our matter should be divided, and this gives us an idea of how our matter looks on a subatomic level. So now we actually can go through and start talking about the way some of this matter interacts. So when it comes to matter interaction, we need to think about their different properties. So I also, in this video, am going to discuss properties. So thinking back, we've got all of our different ideas about what matter is. Now I want to talk about properties. There's two types. One is going to be physical, and the other is going to be chemical. Now it's important to understand the clear delineation between these two. The most important one is that chemical properties can only be determined by experimental data. So when I talk about a chemical, it must be experimented. So an example, let's list some chemical properties. So some of them can be the reactivity, so reaction to air, reaction to oxygen, reaction to water. When I say to, I'm talking about with or in the presence of. So if water reacts with it, the idea is that they're in the presence of one another. Another one could be reaction with acids or bases. Another example, while we continue down this road, we could be talking about the toxicity, the stability. We could talk about how combustible it is, so its ability to be lit on fire. The important thing is when I look at all of these chemical properties, in order to know if something reacts with air, I have to actually do an experiment where I react it with air. To have it react with oxygen, I have to actually perform an experiment where I let it react with oxygen. And if it does react with oxygen, I get a new product. It is no longer the same thing. If it reacts with water, acids, bases, in all these cases, you get something new out. So by actually doing the experiment, you can determine the chemical property. Whereas when we look over here, now we're going to look at physical properties. Physical properties can be determined without actually performing an experiment. So beside me, I have some of my favorite element, indium. And indium's pretty cool because at room temperature, it becomes malleable. So I have no idea if this will react with an acid, a base, fire, if it's well, I do know that it's non-toxic, but that's besides the point. I don't know anything about its stability. I have to do an experiment to figure all that out. But to figure out its physical properties, one of the things I could test for is the malleability, or how ductile it is. So check this out. Is it malleable? Yeah, it is. This is a malleable metal at room temperature. It can easily be twisted, pulled, cut, pulled apart, squished. It's a very interesting metal from that standpoint, which is why it's actually my favorite. It's very twisty and can be messed with. It's non-toxic, so you can actually chew on it. But these are all physical properties. These are all things that I can see just by touching, by holding it, by measuring it. Density is another physical property. The boiling point, the melting point, I can test all of these different ideas just by holding it, by seeing it, by observing it. In no way have I had to do an experiment to test whether or not these things are true. I can simply observe them. So physical properties are easy to determine just by basic observation. So let's just list a couple more other ones. A couple other physical properties I could give: color, texture. I could give the state. I could give you a smell. I could tell you about the crystal shape. I could tell you about its viscosity. I could tell you about its solubility. I could tell you about its conductivity. I could tell you about its heat capacity. And in no way are any of these altering it. By testing any of these, I don't somehow turn my indium into indium oxide, indium nitride, indium metal bonded to something else, indium alloy. It is still the same element as I started with. So testing these things doesn't actually change the outcome. Now, a few of these I would like us to talk about. I'm just putting a Q beside a few of them, because these ones can all have something else associated with them. These ones have the fun fact that they are quantitative. Quantitative. And quantitative just means it can be measured. So when I talk about the density, I can measure its size, and then I can weigh it and determine the density, because density is a function of volume, or mass per unit of volume. I can measure something's viscosity by seeing how it flows down a ramp. I can measure something's boiling point or its melting point just by heating it up or cooling it down. So a couple of examples: melting point, which from here on in we're going to call MP; boiling point, viscosity, its solubility, by seeing how much dissolves in a certain amount of water. I could measure out its conductivity, because we can measure our electricity. And I can measure out its heat capacity. So all of those things from the other side, I can actually measure using numbers. When I take a look at everything else, I can only measure the quality. I can't measure how red something is. I can't measure how rough or smooth something is, but I can have an observation about it in the first place. And that kind of sums up a lot of our theory about matter. In our next video, we are probably going to recap some naming and perhaps a little bit more theory. We might discuss experimental and theories, models, and laws. All right, I'll see you there.